Whoa. Dude's got a beard. Yeah. What's up, Chris?
Hey, who's that?
This is Sandeep. Nice beard, man.
Oh, thanks, brother. Appreciate it.
I don't think you had it at the start of this class, did you?
Yeah, I did. Yeah.
Okay.
Yeah, I got out of hand right now. But
It's all good,
did you finish the homework?
No, I haven't had the chance to work on it at all.
Okay.
Seeing how much trouble we get.
Yep, that's what I'm waiting for too. I tried messing with it. Today, striking out here. So,
Yeah, I just didn't even get around to working on it. These classes are intense enough as it is. 3-hour sessions twice a week. Golly.
Yeah.
Hey, can you hear me? Can you see me?
Yep.
Okay, good to know. So let's see who's here. Only a few people, not everybody yet. We have Justin, Chris, Christopher, Chris. Yeah, we have two Chris's. I didn't realize. And Sandeep. Okay. So I am going to start projecting my screen and start with a quick recap. So here we go, projecting my screen. You should be able to see the screen that I'm showing you. And I'm showing nothing right now, but opening up OneNote, and we'll proceed forward with our discussion that we had the other day, which some of you felt a little bit overwhelming. And yes, I agree. It is quite a bit. It is quite a bit of things that we cover in one exercise. But then what I want to do today is go into detail of not just these, but a pattern, or what I call a variety of collection of different patterns that are repeatable, somewhat reusable across in a variety of cloud scenarios. And those patterns are, good to know, good to understand, and also good to put to use, because what these patterns do is, if you look at the idea of what I would call, let me adjust this a little bit, what I would call a Lego. Lego is something that you probably know already is a toy. And the toy, what it does is, helps you with rebuilding or rather put components together. That we have these pieces of Lego bricks that might look like this, or, whatever shape that they might take. Longer bricks, we have shorter bricks, and variety of components that we can put these Lego bricks together to assemble something more complex, something more useful. The bricks themselves are not that interesting by themselves as such, but the idea is you put them together in a specific pattern, in a specific way of connecting things together, and what you end up getting is what I would call a useful end user usable product. And that comes primarily by putting interesting things together. So those pieces that I'm talking about right now are reusable design patterns. Design patterns. And we will see some of them in our illustration here. We'll see some patterns. We'll also go explore more patterns, and we'll implement them in a couple of different use cases and understand how do we take these things together to construct. So if you look at this picture, and we have done it in this exercise that involved Terraform that we did the other day, and I have, by the way, that GitHub repository that we used the other day, which is where I want to head to. In that exercise, what we did was there was a little error that I found during the discussion the other day, and I fixed it. So that error is now fixed and is available in that Git location. So let me go there, and I want to point out that fix that I have made, which is a tiny little thing that I modified. Basically, that this 2 days ago I made a commit, and the change I made was in this line number 9, where source destination check does not need to be false, but it should be true. It should be kept as true. True is the default. Don't need to change the default if you're talking about application servers. And this is about application servers.tf. But when it applies to your NAT devices, so for example, here is your NAT device. And so in the NAT device, we have source destination check false. It's only for NAT that we have to make it false for the NAT traffic to flow. And so what you're looking at in this Terraform folder are actually patterns of design, a variety of design patterns that we have embedded, put things together in a fashion that will come together to construct a larger, useful architecture for some given application. And so let us now look at the componentry in there, and let us see how we can either, my preferred approach in open source is to just use whatever is there out there. We have actually, if you think about how do you solve a problem from a practical perspective, there are, broadly speaking, 3 ways of solving a problem. 3 distinctly different solving a problem when it comes to what I would call software, but primarily software development. 3 ways to solve a problem. And those 3 ways are, let's go full screen and try to understand what those 3 ways is: to build something yourself, or otherwise you buy a ready-made solution, but that doesn't apply in case of open source. That basically translates to use an existing solution in the open source domain. If you're talking about commercial products, that you have to go and buy them. And the third method of solving a problem is one and 2. This is 1, this is 2. And the third method of solving a problem is don't build, don't buy, but you partner with somebody who has a solution. And those are, broadly speaking, 3 ways to solve a software problem. In general, for any organization, you will see they take these 3 approaches. Either they build themselves, or partner with somebody who has a solution, or just use an existing open source solution. And this is, my preferred way of solving a problem is just use something. It's already there. Why not use it? Because it's open source, you can. If it is commercial, this buy is not my preferred approach. Of course, it costs money. I would rather build it, or maybe I partner with. And then if I really find something of really value, I might buy it. But that's my last choice typically. But when it's open source, this is my first choice. Just use it. And that's the way that I prefer, because it makes business sense. And also remember, when you're using open source, that you want to make sure that you contribute back to them. But whatever changes you make, it's a great idea to just give back. Giving back helps other people, in turn eventually helps you, because it comes back to you eventually. And as you will see, as you build, as you give, things will come back to you. They'll help you. And so you give, and the things with benefits will flow back to you, because that's how open source builds and evolves. So that's the 3 ways of building components, 3 ways of building what I call design patterns. And if you look at our picture illustration, in this picture, you will see that in here, in each and every one of these guys, there is some kind of a reusable component that we have actually used. For example, if you just focus on this segment. Now, if you look at what's going on under the hood, let's go draw it. And let's go see how we can quickly implement that portion, just that portion. And so we'll go to a new sheet of paper and understand what do we have there. We have some kind of a subnet. And in that subnet, we have a box, a computer, a PC, call it a VM, call it an instance, call it whatever you would like, but it's basically a computer that runs some operating system. And mostly in my examples, it is all Linux. You can also, of course, put Windows there, it doesn't matter. And so just, assuming it is Linux, that's the dominant choice, you can put Windows there, no big deal. And so that's the machine that you get. Now, what my preferred way of solving a particular scenario is to not run your applications that you might have directly on this OS. Don't do that. But instead, introduce a method of running these applications in a container. That is my preferred approach. And when you run these in a container, they're basically transportable. You can take them from here to there, make maybe another machine, another computer, another subnet, another region, another cloud, or maybe bring it back in your business, in your company, all inside back to your company. You can take those things, transport them around very easily if you use Docker. And that is what I extensively suggest that you should also use. Many companies who are in the domain of cloud computing are actively using Docker. And that is exactly what we have in this illustration. We have a machine. So we call it app0, that's the name. But in this machine, we have a Linux box. And the first thing we do with the box is we install Docker. And then the second thing we do is to run some app. But then we run the image, Docker image of the app. Run image for that app that we had in mind. So if you have an app, you will build an image for that app and then run it in Docker. And that's a recommended approach in terms of using containers, even if you are dealing with direct machines like this example. So that's one approach. Now we could quickly put this to use in practice. What does that translate to? If you go here, and rather, let me go to the source code. So if you go here and you look at the app servers example, it is basically creating two instances, two count of some instance in some cloud, and it is assigning a size T2 micro, some subnet selection, some security group selection, key pair selection. So destination check is true, you don't want to change it, but then comes the idea of configuring that box. So this is going to just get you a two boxes all the way this way. This segment will get you 2 boxes, but that box doesn't do anything for you specifically. You want to configure these boxes to deliver some result. You want to put some application inside a container and get it to run. And that is exactly what we do in line number 10. What we're doing is we're saying user data, use the file, this file, and do whatever it says. So that is the operative line which configures that particular, those 2 boxes. So we can make count go higher, go lower. So that's a different idea. But just think about a machine. We get the machine, get this image, get this instance type, how big, how small you want, T2 micro, M4 medium, things like that. Choose a subnet, security group, key name, source destination check, and then all these things will get you some machines. They're going to be raw, like plain vanilla Ubuntu, plain vanilla Linux, plain vanilla Windows machines. They still don't do anything for you unless you configure them exactly what you want them to be doing. And that configuration step happens right here. And that is what we do, is we will configure that. So what we want to accomplish in our design is, if you look at here, what I'm saying is get the machine to run some operating system, but then you have to have Docker and then your application on top. Good. How do we get there? We want to get this image ready, first, at the very top, you have to have an app that you want to run. So that app needs to be there. And then you have to have an image that runs in Docker. And then you have to get Docker. And then you put that image on top of this Ubuntu thing. That's what we will accomplish in this illustration. So we go back here and look at that cloud config app.yaml file. You will find it right in that folder. And there's this cloud config folder. If you go in there, cloud config, and then look at app.yaml, in that location, you will find this file will do these exact two things that I wanted. First thing, run Docker. And second thing, run your image of your app. In my example, the app image that I want to run is this image called Nginx. And I did not build it, but I'm using a ready-made image. You can build yourself if you like. You know how to build an image. We have built some simple images already. We'll do more complex things pretty soon, by the way. And so with Docker. And so this runs your chosen application. And this is going to prepare the machine to run Docker. Now, this is a fairly comprehensive step that Docker has already given us. And so if you go and look at that script, it's a ready-made solution that Docker provides. So we can just go there and read. That's a long script, by the way. And so here it is. And it will do lots of things. But essentially what it does is it is meant for quick and easy install via this line. One line install of Docker. So it does a lot of things. And you can read the whole thing. But that's not really necessary. If you're using it, you just go and use it. That's what I did. Just use it. You know how to install Docker. I have given you an Ansible playbook to install Docker on any box. You played with that the other time in previous exercise. But this is a whole lot simpler, quick, simple method, recommended approach from Docker. One line, install Docker. Next line, run your app, and you're done. So that's one pattern. Now, in order to use some kind of an application that you might have an app, you will absolutely have an application that you want to run. For that, you need to create your own application. And that application construction can happen in a variety of forms. For example, I have given an example of a Ruby on Rails application. How do you build an image? And we can do that exercise. I would suggest we'll see if you want to do that exercise yourself. But that exercise is somewhere available here. Let me find out where it is. Yeah, that module number 10 is an exercise. If you happen to have some app custom and you choose the Rails framework to run that app, then these are the steps that you need to do to create your own custom image, which will run your app, not just plain and simple Nginx, which is a ready-made image. You can create your own image by following your own application you might have, and you containerize it. Containerization is a phrase used to make an application run in a container. That's all it takes. So to containerize an app, here is one example. We can follow this if you like, but this is going to be an example application again that I have chosen to run for you, but that may not be exactly what you may want in your situation. Your situation, it will be custom, right? For every given application, there is a custom application that needs to run. And so this is a generalized framework of how do you Dockerize or containerize some application, custom application. So this is a Rails example. And based on this, you can use any other framework to create and customize and Dockerize or containerize your own image. Once you have your own image, you just come back here and say, Docker run my image. And that's the way to get your application run in your instance. So here will be your application running right now. This box comes with Ubuntu OS. I install Docker on top, and then I put Nginx. That's my chosen application, but this may not be your chosen application. So you have to create an image for your app and put that back in place of this Nginx, and that becomes your app. So then your app runs in Docker on top of the OS that is here and here. and more such instances. So this is one pattern of how do you put your applications inside one unit, one box, one, I should not actually call it a box because this is more like a Docker host. We are not using the box or a machine like a server. This is more like used a host for Docker to run. We are not really worried about what that box is as such, because all we really care about is, can it run Docker? If it runs Docker, that's all I actually expect from the machine, because I don't need any other customization. All I need to do is to make sure that the box runs Docker for me, because everything else is already packaged up in my app, in my image that runs on Docker. So I am basically taken care of. So that's how you think about putting your app at a very, very, simplest possible manner, is put that in a container on a box, and then you scale these guys like left and right. That's another pattern, by the way. So we just focus discussing one pattern. The other interesting thing that we did was to use this box. Let me erase this. So we use this NAT box in a fancy fashion in some sense. What we did with this box is we were using this as a NAT device for these machines to go and interact with the World Wide Web through the NAT as they transmit through the gateway. That was the primary focus of that NAT box. And that's the reason why we have a NAT device. By the way, we did not choose a NAT device. In this example, we began with plain vanilla OS. And we tweaked 2 lines in there to get this box convert to become a NAT. What did we do? Recap. If you remember, we went to our Terraform folder and then NAT server, and you'll see what we are doing. We're getting a box right now. See here, we are getting a box, machine image, instance type, subnet, security group, key name. And then we modify some specific things. First thing for NAT is this make it false, which we know already. We have done it manually. We are doing this in code. We are tagging it. The tagging is all cosmetic. This piece is cosmetic. We don't need to tag it, but we can. It's good to know for people to read and understand. It is purely cosmetic. So line number 9, 10, 11. But then we are establishing a connection to it and configuring that box, basically provisioning it the way we want. What are we doing? First thing, converting into a NAT device. So 2 lines, masquerade and forwarding by echoing 1 there. Echo 1 to that file, this file in this location, echo 1, put the number 1 in that file, and start IP tables with this parameters. So that will convert that box, this box, into a NAT device. That's what is one way to quickly configure any box into a NAT that you might have, any Unix box, any Linux box. And then we are doing another role there. We are modifying and injecting another application right in that box. What are we planning to do is making sure that we can have our employees in the enterprise connect to our cloud comfortably, effortlessly. And so we need some kind of a VPN solution. So we can get a VPN solution and spend thousands of dollars on Cisco and Juniper and God knows who. But no, don't. There's no need to. There's no need to, because we have a solution already. And it's right here. It's called OpenVPN. This one. And these guys developed the software, and then people like Kyle, this guy prepared a open source image that uses the same software. So our work is basically done. What we did is we use this image, this Kyle's OpenVPN image that is available in Docker Hub in this location. We just go and use it. Now, most big companies will wonder, should we trust this guy, Kyle? Should I trust my company to this little guy? I mean, he's not little, he's smart. But I'm not belittling him or making him smart, or just any subjective judgments I'm not making. What I'm saying is, if your big company thinks that this guy is not smart enough, that's okay. What I would suggest, and this happens with large companies, like people will question, hey, this dude created this product, should I just readily use it? I personally, I feel okay, but I understand why big companies may not agree with that idea. And I'll tell you the answer to how do you actually convince your company, like, for example, Boeing or Microsoft, big giants don't necessarily trust this group of 46 people who are contributing to this product, which has created an image. They have created this Docker OpenVPN image. But you will see that this product called OpenVPN itself is also open source. It is also made by people like Kyle. And so who do you trust and who do you not? That trust is essentially something that comes through a level of comfort that you have with the product. If you find that this product is actually useful and you're comfortable with it, you will start to trust it. But then the key thing is to don't trust. Begin with, no, I do not trust this. That's the best way to think about corporate security. If you think about Boeing company or IBM company or other big giants, they will not trust anything to begin with. And that's the right approach to think about. I'm not saying that that's wrong, but that doesn't mean that you don't use these things. So how do you then make a trade-off? Like, where do you take this discussion? On one hand, I'm saying, you don't trust them. But on the other hand, I seem to say that, yeah, Kyle is good. So how do you balance these things? That's a question that many people have in the back of their mind, especially in large companies. So Nilesh says, trust this guy. But then he also said big companies should not trust random software on the internet, because that's not how big companies operate. So the trade-off, how do you resolve it? This is how I suggest that you do. First thing, take this product and isolate it in a completely independent environment in your own company. What does that mean? It means you clone it, this clone button, take it locally, read the source code of the entirety of this source code as to how this gentleman, Kyle, has developed that image. And he is actually very nice that he has given you a Docker file which describes how the image is built. This Docker file is what is used to build that OpenVPN image. We'll describe how exactly those people are building it. So they're beginning at the foundation using Alpine, which is a Linux distribution, by the way. They're using the Alpine OS. Maintainer is Kyle. And he's then installing a bunch of things. So you can see what he's doing. You can read line by line exactly what he's getting. He's basically echoing this to a repository listing and adding apt update. OpenVPN is installing OpenVPN, IP tables, bash, EasyRSA, this and that, Google Authenticator, and then making some file modifications, then setting some environment variables and establishing a volume, exposing a port number 1194, which is the standard port for UDP, and then running OpenVPN. And that's pretty much it. There are some more little things. So you need to know what just happened in that image. So when you go to the Docker Hub, and like this, you go to this Docker Hub location and you find that this image is available for pull. You can use that image readily. You can totally pull the Docker image just like that, Docker pull, and this image. You can just pull just like that, just like I have also pulled, by the way. If you look at my example, I'm doing exactly the same thing. I'm referencing a Docker run with that name that will pull this image right from Docker Hub. But I feel comfortable because I have reviewed just now with you. I reviewed the source of how that image was built. The source turns out to be very clean. I already understand how Kyle has built that particular Docker image because I'm able to look at the Docker file, inspect it, and I feel comfortable about the code itself. Now that I have this code, what I would do is, in a test situation, I would begin using the code that he has provided in Docker Hub. Let me go there again. So in here, you will see that this Docker Hub image is available. So I will begin using and testing it, this one. But then I want to go and talk to my bosses and my big shots in my big company. I want to convince them, and they will again have the same question. Should I trust this guy? And the answer to them is no, don't have to trust. Instead, you read the source code and you build your own company's image based on this source. And at the same time, if you don't like certain things, modify that and then build your own image and put that in your own private repository where you can keep your own Docker images inside your company and say Docker pull Boeing / OpenVPN. And then that becomes the Boeing image of OpenVPN. And you come back here to the open source community and thank them. Say, hey, Kyle, thank you for providing your Docker file and your source code of how you build your image. We have used this. We want to thank you. And so you thank them because it's open source. It is readily available for you to be able to use. I think we should check the license also. So you go back and check the license. The license says, and of course you talk to your attorney, but it's an MIT license, which means it's okay to use commercially. And so it is provided as is and no warranties expressed and all that. But that is copyright, Kyle's copyright. So you thank him and say, we are using it. Just let him know that you used it. And that's the license that he's giving you to. You create your own image. Just like this guy has created Kyle Mana OpenVPN, you create Boeing OpenVPN or Microsoft OpenVPN. Or Microsoft has its own VPN solution, so they will not use OpenVPN, but they can. Nothing prevents them from. And any other company like this, not specifically Kyle, but you come up with your own build using the same source, and now you can tell your boss, hey boss, we are not using Kyle's image. We are using our own image, which we have created ourselves by using the source code available here and modifying it to suit exactly how we would like it to be in our company. So this image that we are going to use is our own image. And now it gives your company a whole lot more credibility and some kind of a level of comfort in dealing with your own creations that are derived from other people's open source contributions. And that is how you start taking open source. And while you do that, you might end up modifying certain bits and pieces in this scenario, in the source code. You might want to change something, and that change should go back to the community. So you should send them a pull request. You know what a pull request is. We did that exercise. There are these pull requests that people have sent. So they're sending a pull request to use Gen Kubernetes secrets to hold config and credentials. So somebody created some changes, 5 files changed. So these changes of 5 number of files. So here is one change, another change. Somebody contributed this thing back to them. And so Kyle will look at it and he may agree to take it or not, depending on whatever he decides. But then the contribution has come back from this company, Stream Insight. Those guys took Kyle's code and then gave back to him. And that's a modification, an improvement in terms of using this piece of code, this piece of image. That company also modified, created their own, and they're probably using it, but then they modified it to create their own Kubernetes scenario. So they are contributing it back to this origin where it came from. And that's the spirit of using open source. Now back to our design patterns. If you go back here, what we did in this example is not only created a NAT, but also put Docker in there and put OpenVPN right in there. And when you are in the context of a large company, you should create your own images and don't truly rely on an image provided by somebody else. Because even though we are saying that we are going to use this image for a large company, I suggest that you don't rely on this image. You absolutely create your image yourself using the source code here. And you will see that example in many, many cases. You will see, and let me show you an example, quick one. When I am using open source in production, you will see some examples right now. You will see that I am going to use some WordPress. So you will see here WordPress. Even though WordPress is a big company and lots of people use it, thousands and hundreds of thousands of people use it, I have a WordPress image that created by me that I use. Now, how did I create this image? I used open source by somebody else. So there is a Docker file, and this is a image that I am using open source WordPress, but this is my own image that I create the WordPress container using my own customizations, and it has my own favicon, my own htaccess, and this is exactly what you see when you visit this site. This site that you're looking at or is going to open up, this site is actually running this container, the WordPress container maintained by me, and it is sitting in my location. I am using WordPress, but not relying and making my business rely on other people's shoulders. I use their source code, I give them back, but then I am running my own images. Like here, for example, I have an image corresponding to this in the Docker Hub, hub.docker.com. You will find that in here, if I sign in, I hope I still have my login information there. And I should be able to sign in successfully, and I log in, and you should see a WordPress image right in this location. If you go and search for the Cloud Genius company, and then search for lots of images here, and one of them will be WordPress somewhere down the chain. I don't know where it went. Maybe I'm not able to search, but there are lots of images that I create, that I maintain for my own use. In this location is an example of a open source based image that I have created for myself using sources provided by others that I'm using to construct my own application set. So now that is what we did in this piece of our design. Now, if you look at the bigger picture, there is not much here. There is an application running here, another application running here, and a VPN running here, and a NAT running here. But we have used a ready-made service here called Load Balancer. This service is a service. It is not a software, and it's a ready-made service. So by the way, there is a ready-made software also available to accomplish the same thing. This idea of a load balancer essentially is this software. This software that is coming up, it's called HA Proxy. It's the industry leading open source product. The website looks kind of childish, more like Craigslist than anything else. But trust me, this is fantastic piece of software. And this is, I think, the foundation behind all the load balancers you see, like Amazon's load balancer, or Microsoft load balancer, or Google Cloud load balancer, and companies like F5 Networks. This company probably uses HA Proxy under the hood, and they're a big company. They're doing primarily just this to begin with, is use this software, which is a reliable, high-performance TCP, HTTP load balancer. That's a product called HA Proxy in the open source. And as you would expect, there is a Docker image ready for that. So you can go hub.docker.com and HA Proxy, you will find it. And it should be right there. So you could use Docker pull HA Proxy as the image to construct a load balancer for yourself if you are not using the Amazon Elastic Load Balancer service. That's a service, by the way, which means it costs you money to use the service, more than it would cost to just run a box here or a bunch of boxes here as your own. If you remove this load balancer service, and you put instead a plain vanilla box that runs HA proxy software, proxy, that's what you will essentially receive. And that box will be able to balance the load across multiple machines like that, just like that. And that piece of software is going to run this thing, HA proxy. The source code is not that. Source code is somewhere maybe here. That's where the source code is available. You can go and grab it in the source form right here. 1.75 stable is a good one. And it was created, the Git repository is right there. You can see the Git source. But the easiest way to get this to put this to use is actually use the ready-made HA proxy image that is already available out there and maintained by the official company that is behind HA proxy. So this is a official image available that, so it is trusted to begin with. And you don't have to trust, as I said, but you can build your own HA proxy images if you decide to use this service. But you will say, how do I know what's going inside in this image? Somebody created this image. How do I know what is inside? So you can see that right here and find out what supported versions and tags are available. You can see that the latest tag available is actually 175. And so if you go read further, there is a Docker file for that. And so if you go read the Docker file, you will know exactly how it is built. And right here is the HA proxy 1.7 version Docker file. And you can see it is beginning from Debian, the Linux operating system, Jessie backports. So it is using Debian as a foundation, installs a bunch of things, 1, 2, 3, 4, and then sets some environment variables, and then runs it. It's some setting more, and then eventually run it. At the end, you will have a Docker entry point, and you will run the command HA proxy with some parameters, with a configuration file actually. And that is what will run HA proxy in a Docker container on any Docker host that you want. So it will just take this application, which we have in mind here, HA proxy, and make your own load balancer. How does a machine become a load balancer? Simply by running HA proxy and putting appropriate configurations in there. There is an exercise for this action also somewhere in here in our write-up. You will find an exercise for just that. I will find it. It should be there in this listing somewhere. It's not written down properly, but I've just introduced that exercise to use HA proxy as a load balancer for yourself. And that is useful somewhat in a case where your infrastructure that you might have in your private cloud may not provide for a ready-made load balancer. In that situation, it becomes very useful to have a load balancer so you can scale. And that's the scenario which comes into handy. So somewhere here you will find it, or maybe search it. I hope search works. I've never tested search, but it might work. So nothing to show right now. Search is not functional yet on the site. But having said, the pattern of being able to balance a load on a bunch of machines, pretty much like, have a load balancer and you want to balance that load across multiple machines like that, you will have to create a load balancer yourself. You can use HA proxy software for that and provide it a configuration file that will basically tell, I have machine number 1, 2, 3, 4, and 5 of them, and I want you to load balance across these 5 guys. So that becomes your own load balancer, which is nothing but a Linux box. A Linux box running Docker and then running HA proxy. That's the simplest, easiest implementation of a load balancer for yourself if your setup doesn't actually provide you a load balancer service. If you are in a cloud that doesn't do, for example, there is this cloud that I think they just started, DigitalOcean. They started a load balancer service. They did not have it, but I'll just check whether they have a service or products. Let's see what products they have, and they should tell you whether they give you a droplet block storage service, networking, monitoring, apps, teams. Where's the load balancer? RESTful API. I think if the network part will have a load balancer, I think. Let's go search. Yeah, there it is. So they started giving you a load balancer. This is a fairly recent development in DigitalOcean. There are still many cloud companies that don't have a load balancer solution because it is not critical. I mean, it's a very nice to have, don't get me wrong. It's a very nice thing to have ready-made load balancer, elastic load balancer from Amazon, for example. So you don't have to worry about configuration and managing and operating all these things. Now, this design pattern is worthy of exploration, further exploration, like to how do we put this configuration to use in a realistic scenario. What does that mean? From a realistic scenario, what I mean to say is a classic scenario where this thing actually applies goes something like the Department of Motor Vehicle or Department of Licensing or whatever other departments you will call. You've seen those things. You go there to get what? A license, right? So there are these officers that will sit in the office, and there are lots of them. Sometimes there are not many, sometimes too little, sometimes too many, depending on whatever the situation is. And there are these people who come in line, person number 1, person number 2, and like that, and 3 and 4 and 5. Lots of people waiting in a queue, waiting for their turn for them to be processed by a driver license officer. And so there is typically a cop that will say, you, sir, should go to this window, and you, Mr. Number 2, should go to this window, and you should go here, and this guy is eating lunch. And so you have these number 4 and 5 and 6 and 7, and lots of people are just waiting in a queue until the processing of these guys finish with these people. So these are customers, and these are service providers. That's a common scenario that you already have seen, probably gone through the pain of sitting here and waiting forever. And to address this situation, you have a load balancer right there. What this traffic cop, or rather load balancer, needs to do is he or she needs to understand how many officers are there. Maybe more, maybe less, maybe the officer goes away for some other reason, right? They might come and go, and sometimes they go on lunch, sometimes for some other reason they're occupied. So you have a queue building up and lots of people waiting and getting bored, and you have only 2 officers to serve the people. And so what should happen ideally in an ideal situation, you should see that lots of people waiting, and a queue of people getting bored and frustrated is growing. In a logical fashion, you should automatically ask more officers to come and help out. You would expect that to happen. And when that happens, you would also expect that this cop somehow magically figures out that there are these new officers that are now in service, and that I can take these other customers and send them here for service. And sometimes, this officer can go on a break. And so when that officer goes on a break, the cop needs to know that there is nobody here. And so that this person, the next person should not be sent in that direction. Instead, asked to wait because there is nobody to actually service them. And that logic is exactly what a load balancer does. Now, the scenario that we are talking about is that this scenario of growing and shrinking, grow, shrink. This scenario needs to be not like government. It should be automated. It should not behave like or look like or feel like government. because, in the government, you have, people going on lunch and they may not be available, and only one officer today, and now everybody is screwed. And so that's the typical scenario you might see, in some situations when it's not automated growth or shrinkage. You've seen this, right? I hope you relate to the example I'm talking about, because what this translates to is you have customers visiting your website and you have a load balancer that is going to assign the load to a bunch of machines that you might have running your application. And these machines should grow and scale out and scale back in automatically. Scale out and scale in should happen automatically. And that auto scaling is a design pattern that you need to understand and put to practice. Have you played with this scenario ever yet? It may be in any other case. I just want to know if you're familiar with this thing, or because I want to run an exercise on this idea right now. So if you understand this scenario, I would like to know that you do. Basically, I'm looking for some feedback. Do you know what I'm talking about in terms of scaling in, scaling out, of automatically scaling your applications that you have?
Absolutely.
Okay. So have you played with this, Chris, by the way? Have you played a real life scenario with this auto-scaling?
Gigantic load balancers, gigantic ones. Like, for instance, Xbox, whenever we start to sell a boxing match, all sorts of people start lining up for the tickets, but there's not enough servers, so auto-scaling through Azure will allow more interfaces.
Yeah. So what I intend to do is, for those of you who have not seen such an auto-scaling thing in action, I want to run it for you and let us play with it. So we will go to Amazon and see if we can get to a quick, simple, and meaningful example of auto-scaling. So I'm going there right now, and I will logging in, and I will use a CloudFormation tool to quickly start something for us that addresses the need for us to understand auto-scaling and put that to real use. Like, we'll actually simulate load and simulate customers coming in and see what goes on in case of a real life scenario where how do you see that machines will scale. That scenario, I'm going to build it. And as you know, I'm going to use automation to build the scenario, and I will use another automation to drive that scenario and actually put load on it and see things scale. That's our goal in this next exercise, which is a live exercise. And I'm going to type in my token to go in here, and we will create everything from scratch as usual. And typing my number. And what I'm going to do is identify an example CloudFormation template. So they have given us, Amazon gives us a variety of templates for us to use. And so in here, if you see some sample templates, you will find that there should be an auto-scaling template right here. And in here, you can see that there are these three cases: load-based auto-scaling, time-based auto-scaling, and auto-scaling group with an update policy. So the one I have in mind is this one: creates an auto-scaling group with auto-scaling policies that are based on CPU usage in order to start and stop EC2 instances, which will span multiple availability zones. And the template should also use auto-scaling notifications so that you are emailed when scaling events occur. So that's the description here. And what I want to do is create this setup. So all I need to do is just quickly launch the stack. That's all it takes. It'll launch a stack for me right now. And I will have an auto-scaling setup ready that is based on CPU consumption. So the stack file, it's called a template, is already loaded up right here. It is a ready-made template that I'm going to use, and it will help us demonstrate auto-scaling. So I go proceed forward next and understand that I will be using T2 small instances I'm using my key that I have here called ID underscore RSA, or yeah, this one is good. Then operator email. I need to receive notifications when automatically machines get added. Like, you add more machines here. So another machine added, another machine added. I need to get notifications. And a machine dies away, a machine was killed away. I need to get those notifications. And this machine goes away. I need to get email notifications, which is where I need to provide my operator email. And then I'm going to be able to connect to my cloud through any location. And then I'm not specifically choosing any particular subnet. So I'm leaving them blank and not giving a tagged value. I think I want to choose this whatever cloud. The name whatever is just something I crazily typed, but it's basically my default VPC. So this VPC is my default VPC. I don't care which subnets get chosen. And I'm going to select that in T2 micro, ID RSA, my email address, any location on the internet. Don't select any subnet and choose the virtual private cloud I have in mind. And in that VPC, in the Oregon region, right there, I will go and set this up. And what you will see is it expects me to proceed forward, and is going to give me a cost estimate as to how much will it cost me. You can see that the cost estimate it comes up with is basically a scalable number, and it'll tell you how much it'll cost, something like $18.94 per month, which is fair enough. So that's the cost, $18.94. I'm expecting to pay that, which is on a monthly basis, which is cool. And then I will check my details. Are T2 small machines. ID RSA is the key that I will use. And this is the operator email, and I'm choosing to construct that setup in this VPC ID. So I will create. And when I click the create button, creation starts to happen. And you can see that the creation, did I click the create button? I think I did. Yes. So where is the creation? Where did it go? And come on, show me. Didn't I create the button? There it is. So it says rollback complete. I mean, it did not like itself, apparently. Something did not happen properly, or it didn't like the way I was doing, or something else happened. So we're going to read it. It says parameter failed. Parameter value for parameter name subnet does not exist. Okay, I had to choose a subnet apparently. So I'll go back again at the very beginning, and this rollback is complete. So meaning everything was destroyed already. I'll launch the stack again, and then I should choose a subnet, which I will this time. So go next. And then I have my T2 small, my key name is ID RSA, operator email is Nilesh. And then I will choose my VPC and then choose my subnet ID and another. So 3 subnets. And in the VPC. So the VPC and all the details are correctly selected this time. We go forward and go next. And then I will choose these 3 subnets in this VPC and then say create. So this stack creation error says this name already exists. Fine. Okay. So I will refresh again and destroy that thing first before I create it. And so I need to destroy that. It should have destroyed itself, but no. So I will go and destroy this name, delete stack, and say, yes, delete please. And then it is deleting right now. Then I'll go back and do it again. And next and third time should be a charm. And so here we are looking at those 3 subnets again, and this VPC, and next, and next, and create. So when I click the create button, I expect to see the result, not this screen. That's a bug. Show me the result, please. And something is happening right now. So some creation has started. Okay, let's see what it did. So it is still doing it. And so the load balancer got created, some notification topic got created, target group got created. So let's go and see the Oregon location. In the Oregon location, let's see in the EC2 section, what do we have? So we should see some machines getting started in the EC2 segment. At least one or two should show up. Depending on, I think two should show up. Let's go see how many are showing up right now. So I think it's work in progress for right now. Let's go see load balancer. Do we have a load balancer there yet? Yes, so it is provisioning right now. Once the load balancer gets provisioned, we should see some machines getting created and start to become a member in the load balancer group. And you will see those machines popping up in here. But right now, I will go back to my CloudFormer tool and see what the tool is doing. So CloudFormation should show us the results. And we are expecting to see just one traffic cop and two officers serving a bunch of customers. That's the expectation from the design. The creation is still in progress. So we'll wait for it. Should take a minute or two and then finish. You will see that we will have a setup that looks kind of sort of like this, pretty much like I had drawn. We will have customers. We will simulate customers, by the way, by putting some load on it. We will have a traffic cop that is called Elastic Load Balancer. And we will have two machines. And we'll see how the policy of grow and the policy of shrink comes into play. The shrink policy and the grow policy basically applies to the scenario where you have machines running your applications. The number of these machines will grow. This is the grow policy in action.
So Nilesh, is it the load balancer itself that determines the elasticity or the requirements of how many machines you're using? Is that what we're saying?
Yeah. So the policy determines it, not the load balancer.
Okay.
And the policy is what will decide when should you grow and when should you shrink. The grow policy and the shrink policy basically determines when a machine should be added or removed. So that policy is what we will have to understand. By the way, it really, really depends on the given use case that you have in mind as to what dictates the grow policy and what dictates the shrink policy. It really depends on your use case. For example, in our Department of Licensing use case, the grow policy should be the level of boredom that these guys have. If they're really bored, maybe give them another officer right there, or maybe more, so that the people are serviced faster and they get less bored. That's one way to handle that. So you measure boredom. So you have to measure something, right?
Sure.
So you measure, sorry?
I said, sure. Okay.
Yeah, so you have to measure something. I'll measure boredom of the customers and see if they're really getting bored. If they're getting entertained and sitting at DMV, I don't need to worry about O2 and O3. They can just do whatever they're doing because people are happy in being at DMV doing nothing and waiting. There is no reason to worry about anything because people are enjoying themselves. So let them do it. But if they're getting bored, I want to measure that boredom. And based on the measurement, I will trigger something. And the trigger will be, okay, bring in more officers, please, because the level of boredom has exceeded 0.75. So I want to bring the boredom down to less than 0.5. Or I'm making these numbers up, but you get the point.
Hey, Nilesh.
Yes.
Who is the observer that is making these metrics?
I know. That's a good question. So the person who is putting this thing together needs to be taking that role. He or she needs to set policies in place and metrics in place to decide when should you trigger and when should you not. Or rather, I should say, there are actually two ways to think about it. There's a grow policy discussion and a shrink policy discussion. So both we have to understand from a business perspective, what makes sense to grow, what makes sense to shrink. So now in case of DMV, you can talk about boredom. how much bored people are. And so boredom metric increases to 0.75 and goes higher. And it stays like that for a period of, say, 3 minutes. And people are still bored at the same level or more, 0.75. In that case, maybe I should do something about it and bring it down and add another officer number 2. That's my grow policy, right? If my boredom level, or rather the number of people waiting, this boredom actually is not a good metric, right? Better metric is to see, you can assume that people primarily get bored when they're doing nothing at the DMV. That's a good assumption. So maybe boredom is not a metric because that's a given. Everybody is bored by default if they're doing nothing. That's an assumption. So the metric needs to change to number of people waiting and how long have they waited, duration. And based on that metric, we have to come up with some thresholds of, if a person, number of people waiting is 3 and they have waited for more than 10 minutes, maybe it's time to get another officer. And similarly, if the number of people waiting in line is 0 for more than like 20 minutes, maybe the second officer can go away or go do some shopping, or just do something else, like some back office work, something like that, some other random work. Because there is no need to have 2 people because there is nobody waiting for 20 minutes. He can take a break and come back and have some coffee at Starbucks and come back and do the work again, because there's not really anybody to take care of. So the number of people are 0. So it's a good idea to shrink them. In fact, if you have a scenario where the number of people is 0 for the last 1 month, there is something magical going on there. Apparently DMV, nobody shows up. What's going on? Something is wrong. Or maybe you have overstaffed your people. So maybe you should think of a layoff of number of people employed as officers in the DMV, where nobody seems to be visiting your DMV 0 for the last 3 months. Nobody wants a driver's license. Only one person is able to, officer number 1 is able to handle all of them. The second officer is sitting idle. And that is a situation which is worthy of a layoff. So maybe you should lay them off, or maybe give them another work, like go do something else, or maybe transfer them to another department. But basically, shrink policy. This policy applies. So that's the grow and shrink business, the way of thinking. Now, when it comes to applications, we have to think different. Let's go see if there are some results available from here first. And we'll see whether the construction is completed. It looks like it's completed. So we'll go and see it in a minute. But here, from an applications perspective, there are these policies that we have to write. And the business who puts things together needs to create them in a matter that focuses on the customer. That's the only thing you should focus on when you are deciding whether to grow or to shrink. The only thing that should dictate is customer experience. Everything else is BS. We don't care. Honestly, you should not care. It doesn't matter. So if your customers are happy, you have to, and by the way, this customer experience is a very vague term. Vague in terms of measurement. It's very vague. But that's the only thing that truly matters. It's very difficult to measure customer experience. Are they delighted to visit your site, your app, your services on the internet? Interesting. How do you measure that? That's a hard one, really hard one. So you have to come up with proxies to proxy metrics to understand customer experience, which is somewhat of a trade-off. But in reality, it is extremely difficult to identify whether say I am go to this Amazon app, and Amazon app opens up and it is connecting to the Amazon.com website, and it is going around in circles right now. And I am frustrated because the number of machines that Amazon has on the back, it's still not loaded. I mean, this is way too crazy. Took a long time, like 5 to 6 seconds. That's bad. I mean, that's right there bad. For Amazon, 5 seconds is way too bad. For Cloud Genius, 5 seconds, I feel happy about it. For this site opens up in this site opens up in 5 seconds, I feel really happy about it. But for Amazon's website, 5 seconds, way too long. And it's not good, honestly. So that's one metric to let us understand whether customers are happy or not, is how quickly the site responds to the customer. And I started the app, the Amazon app, and it's going around circles waiting for 5 to 6 seconds while I'm talking, and that was bad. From Amazon's perspective, my expectations are way too high. And I expect Amazon.com to function flawlessly all the time, like sun rises like that every morning. I expect Amazon.com to be up and running all the time. That's just my expectation, by the way. Maybe I'm stretching it. But that's exactly what a proxy is for a customer experience. You have to come up with proxy metrics that will really translate customer happiness to something like site load time or responsiveness, or search results, how fast you can get search results, or other metrics that you come up with as a proxy that are really translating to measuring this thing, which is really, really hard to measure. It is a very valid thing to measure, but it is a very hard to measure because by definition, experience is vague. So we have to translate into proxies that help us understand somewhat of how the customer might feel or perceive your application. And depending on that, you decide how and when should you grow. And similarly, on the other end, how and when should you shrink? The shrink policy is also very, very important, and it also translates to customer experience. Customer experience plus avoiding wastage. Avoiding wastage is also important. That plays a very critical role in the case of shrink policy. You have to account for the customer experience not getting deteriorated, at the same time making sure that you're not wasting money. This avoiding wastage is critical also, not just this piece. You can grow all the time, and making sure the customers are happy is all good, but then you don't grow beyond a certain limit where the incremental benefit of growth does not translate to a positive increased customer experience. So if you have like 3 officers here already, and 3 people, and then they can be assigned like that, and there is no need to have another officer just because you can. There's no need to. So this officer addition was not necessary, even though you have all these customers waiting are already being served. So you just added a machine. That is a bad idea, because this deserves shrinking. The shrink policy
and that's like the law of diminishing returns, right?
Right. So you have to understand, when do you shrink? When do you get rid of this guy? And then that policy has to be very systematically written down. And so in our example that we have just put things together in this place, it seems to have completed. Let us go see what that actually does for us. So we'll see the policy also, by the way. They'll describe the policy right now. We'll go first see in the EC2 section, what do we got? It seems we have just one instance. And so let's go see what that does. So this instance is, as you can see, is a T2 small, which is expected. Instance is running, and it has a public IP address. Let us see what else we have. We will look at our, where is the load balancer? Here, load balancer. And in the load balancer, what do we get? It is loading. Now this loading is also a bad experience for me. I expect Amazon Web Services to be flawless, but I get sometimes not. It is not too bad, by the way, but I'm just nitpicking. It is not too bad. Azure is bad. Azure website, try opening it up and see how slow it is occasionally. That is bad. But here you see that in this load balancer, it is active and it has a listener listening to one box. Let's see how many boxes it is listening to and what are the, let's go read the whole thing one by one. So at the very top description, the scheme we have is an internet facing load balancer. The load balancer was created active in this VPC and the security group is in place. That's the description section. Let us go see the listeners section. In the listeners, what do we got? We have a listener listening for port number 80, HTTP protocol, and the monitoring action is happening right now. We can see what the monitoring action is. Essentially is a collection of metrics that are being measured. You can see these metrics are being collected for the load balancer itself. Now, having seen this segment, if you go back to EC2, look at our running instance, you will find that that running instance has a status check, which shows that it's green in color, which is passed the test. We have a monitoring tab, which shows us the performance of that box. Its CPU consumption is fairly low, 0.3 started with, and it is kind of, you know, it's not big, 35%, that's max. That's what you're looking at right now. Other metrics, discrete operations, write operations, network, the metrics are being collected and you can see the metric graphs are being constructed, and that's what you're looking at. However, if you now look at our auto scaling launch configuration, here you will find something that is of interest to us, because that's where it will see that there is a launch configuration in place, and this decides what type of machine will be created when you want to grow by one. When you want to get a new officer, this 03, 04, 05, you want to get something new into service. You want to find out what do you want to get in the service. You want to get a new application server running your application. You want to know what type of thing, what thing should we get. This thing is described in the launch configuration. What do I get when I want to get something added? What do I get when I want to grow by one? What do I get? That what configuration should I pick and choose to add? That is defined in the launch configuration. And that thing is called out here. And that is the launch configuration called out. It says I will use this AMI ID. I will choose a T2 small size, and it will be using the key name IDRSA, which is my key. And that's the configuration that will be used to add one more box when you decide to grow. The grow policy kicks in, right? We'll look at the policy next. So this is the launch configuration for growth. Now, we look at the auto scaling group. And here you will find that this auto scaling group, let me adjust. This auto scaling group uses this configuration that I mentioned already. And here it has some details that we have to go and look at and understand those details very carefully. The details are that this is going to use this launch configuration, and it will have a desired number of one officer, one machine, one application server. Minimum number is one machine. Maximum I want to spend on is 3 machines, 3. And health check. I will check the machine health. Then I'll health check grace period, 0 grace. Termination policies, when the machine wants to be deleted, you want to shrink, you want to just use the default termination policy, which is basically destroy. The creation time of this auto configuration group was June 2 at 5 p.m. GMT. And other details here, we are choosing 3 availability zones, 3 subnets, and cooldown default is 300. That's the detail tab. Let's go see other details here. Activity history, what do we got? It successfully launched an instance, the beginning instance. It launched this beginning instance because it describes you in very clear language as to why was it launched. It says, at this time, a user request update of this auto scaling group constraints to minimum of 1, maximum of 3, desired of 1, changing the desired capacity from 0 to 1. The desire was 1, but initially we had nothing. So this auto scaling group successfully created 1 launch configuration with 1 unit, 1 box that changed the desired capacity from 0 to 1, because that's what your desire was. And then it says, at that time, an instance was started in response to a difference between the desired and actual capacity. The actual capacity was 0 to begin with. The desired capacity was 1, according to your desire, like you mentioned. And as a result of the difference between the desired and actual capacity, the increasing the capacity from 0 to 1. That was the event that happened successfully. This is the activity that you're looking at, and the details again are 1 desired. Now let us go look at scaling policy. The scaling policy is in 2 parts. You can see those 2 parts right here. One of them is the grow policy. The other one is a shrink policy. And we'll read that in detail. We'll come back to this. Let's go finish the other tabs first. So instances. We have 1 instance right now, which is this. Monitoring. We are actually collecting metrics and it is telling you that this particular group collection metric is not enabled in the auto scaling group, which is fine. We don't need to worry about it. It's not going to cause trouble. Notifications are not enabled. So meaning I will not get an email, which is fine. I'll just look here whether the machine got added or not. And notifications are apparently going to be sent, but then there is a monitoring notifications. Auto scaling multi-AZ notification sample web server group is something is not enabled. We'll worry about notifications later. So notifications, email, tags, and scheduled actions. There are no scheduled actions as such. Now go back to our policy. We have 2 policies in place. The add policy and the remove policy. This is the grow policy and the shrink policy. Now let us understand what these policies are and how do we get these policies to actually play out in real life. I will exercise this policy by simulating what it expects. Like for example, I can simulate more customers visiting the DMV and getting bored doing nothing, waiting. That I can simulate by sending people. And so I will similarly simulate whatever it takes to enable this policy to get exercised. Meaning I will proxy something, create something fictitious and basically simulate workload on the boxes to make the policy believe that there is a need to grow. I'll make it happen. I'll show you live. But first, let's read the policies. So here, the add policy or grow policy basically means it has a longish name. AS multi-AZ notification sample web server scale up policy. This up and down is not according to how I describe scaling. As you remember, I describe scaling as in and out. And to me, up and down scaling is different. It is not in and out. When you scale out and scale back in, so you grow horizontally, similar size machines, you grow out and you shrink back in. That's scale out, scale in. This nomenclature doesn't match what I describe, but I hope you understand that. This nomenclature, actually, I don't like it, but this is Amazon. I cannot do anything about it. So this up and down is actually about machines getting bigger and smaller. That's how I describe. Amazon doesn't like that method. Apparently they like a different method, whatever, don't care. But remember that this up and down actually means out and in. This up means scale out, and in, down means scaling back in, shrinking. So this is the grow policy, grow and shrink. Those two policies, we'll read them. So execute the policy when, and let's read the condition. The condition is something, some name, notification sample, CPU alarm high. When some alert breaches the alarm threshold, CPU utilization is more than 90 for 2 consecutive periods of 300 seconds. In that case, when you have 2 consecutive periods of 300 seconds, for the metric dimensions on these web server group, then when you have a CPU workload of more than 90 for 2 periods of 300 seconds, which is what, 5 minutes? Yeah, this is 5 minutes, right? Yeah. Yes. So total of 2 consecutive periods of 5 minutes, basically total of 10 minutes. If you have the CPU consumption more than 90 on the box that we have only one, and the CPU goes beyond that to say 91 or higher for a period of 10 minutes, then you do something about it. What do? You add a box. That's what is expected. And then don't rush into shutting down the box if the CPU consumption goes suddenly below 90. Don't rush shutting down the box by itself, but wait. This wait is a critical step to include in a policy. So you grow, add an instance when you see that for more than 10 minutes, you have CPU utilization above 90%. You add a machine and then wait for 60 seconds before allowing another scaling activity, grow or shrink, whatever you have, any of those two. You wait 60 seconds before you allow something else to kick in. Don't rush into executing another policy right away. Do you know why this wait is important?
Yes, because if you were to downscale or n-scale, as you say, too fast, there may be more traffic right after. There's also the problem of sometimes you scale out and it happens too slowly, and then the traffic and the need for it already is surpassed. Couple problems.
Bingo. So this is what I call a flip-flop problem. You suddenly flip-flop, meaning you flip and then you suddenly flop again, and that becomes very, very noisy from an electronic signals perspective. Talking in simple words, if you start a machine and you figure out that the metric suddenly went down, you don't have to suddenly stop the machine away. Just hold on, wait for a minute, think about what just happened, do your calculations again, wait for this 60-second period before you start your policy execution again, and you start collecting metrics one more time. And then, say for example here, the shrink policy. A CPU utilization is less than 70% for 2 consecutive periods of 300 seconds. So meaning for 10 minutes, CPU is below 70%. Now what do? You remove an instance, right? That's what this policy will kick in and cut the machine. You will see these things happen right now. And by the way, when you remove a machine, you just wait again. Wait for 60 seconds before allowing any other scaling activity. So you just shut up and wait for 60 seconds, do nothing, just wait and watch. That's the policy. That's how this policy is written. Now, in order for us to exercise this policy to be able to add one instance, what do I need to do? I need to somehow magically grow the CPU utilization for 2 consecutive periods of 300 seconds. What does that mean? It means I need to load up my box. So I have that box there. The box is, where is my box? Come on, so console. And I have that box there, which is in EC2. And come on, box, show up. This box. This box has a CPU utilization right now. Let's go get the IP address first. So the IP address here, and let's go connect to the box like right now directly. Boom, and we'll go connect to that box and see if it lets us in. So SSH Ubuntu at IP address. Is it Ubuntu or EC2 user? Probably it's EC2 user. It will fail probably. Yeah, it'll fail. So SSH EC2-user at IP address. That's the login name apparently it uses. And so now I'm connected. Yeah. So on that box, I'm connected. And I want to just quickly measure my CPU activity. How much is the CPU here? So I will have to run pop. And I can find out my CPU activity. And you can see that the CPU activity is fairly low because the box is doing nothing. The load average on top is 0. Okay, so I need to load it up. So how do you load up the box? You give it some fictitious workload, right? I will find out how do you give fictitious workload. So I'll say stress CentOS. Run stress. Let's see, run stress CentOS, and there should be a method to run stress here. How to stress CPU on a Linux machine. There we go. So it should give us a instruction to stress test that box, and you have to install stress and then run stress. How do you run stress? So there are some examples I can see here. There is a compile. I don't want to compile. I just want to run. So first of all, I need to install this package called stress on that box, which I will do. So I'll grab that package called stress on the machine, and I will run that installation on that box so that I can stress the box itself. So I'm installing the stress application, and then I will invoke stress. So I'm going to stress it for more than 5 minutes, more than 10 minutes, right? So I'm going to figure out how to stress. And the syntax is, for example, let me make it big. For example, a load average of 4 is imposed on the system by specifying 2 CPU bound processes, 1 IO bound process, memory allocation like this. So this is how you do it. Okay, so I will stress my CPU, stress -C4. How many CPUs we got? I think we just have 1. Let me just check how many CPUs we have. So we got 1 CPU right there, and about 2 GB of memory, and the CPU utilization is very low. So that having understood, I want to now stress it. So stress -C1, and for how long? We have to type it duration. Or the stress CentOS for 5 minutes. Let's go see how to do that. How to impose stress, which is the best link? Server fault, that's a good one. Okay, show me a quick simple answer. IOStat, no VMstat. I'll just read the man on that stress and figure out stress. And the option is -C. So stress -C and number 1 for 1 CPU, and then what time? How do you specify time? Timeout after n seconds, so -T, and then I will do this for 600 seconds, right? That's the expectation. 2 times 300 seconds is 600 seconds. So I add some more. So I add 10 more seconds and then let it stress. So it is stressing right now. And I'm running stress-C1 CPU for a period of 10 minutes, 10 seconds. That's 610. So it is dispatching some hogs, basically dummy work, hogging the CPU. And that one CPU is getting hogged right now. You can see this hogging happen by connecting to the machine directly. Again, let's see, SSH EC2-user at IP address. Okay, come on, IP address. On the window that I'm currently running stress, I am running stress. So I want to grab another window and then check out how much stressed the machine actually is, for which I need to grab my IP address, which is what I'm going to do right now, is go to the dashboard in EC2 and then grab my IP address, which is what I'm looking to find. The IP address of that machine instance is, come on, that's the IP address. So I'll grab it, copy it, go back to my VM and check out how the machine is doing. And I can see that my machine is fully stressed out. CPU is 100% right there. On one window, you should see that the CPU edge top shows you 100% hogging. And on the right side, you see the hog, CPU hog 100%. Stress is running in the left window. So on the left window, you have what just happened. Yeah, it is running stress. Yeah, right there. So stress-C1-T610 is going on. And on the right half of the screen, you can see that the CPU metric is all the way 100%. So what this is doing is stressing the box out. Which box? This box. And we'll go and read our policy. What is the policy we have? We'll go and see that again. Our launch auto scaling group policy for launching one more instance, right? That's what we are interested in, is to see what scaling policies we have in place. And we know that the scaling policy is more than 90% for 2 consecutive periods of 300 seconds. So we have 610 seconds chosen. Good. That should kick one new machine automatically generate without me doing anything. It should just pop up. That is what my expectations are, because I am expecting the policy to kick in. The policy is to grow. Grow what? Grow one more machine. And that should happen because we are loading up the machine, right? Right now, where's the machine go? California, go to Oregon, please. Here. So in Oregon, we have that machine there, and there is one running instance, and we can see the metrics on that machine itself should also show monitoring tab, and boom, here's the arrow going up, utilization going way high. This chart shows you the CPU utilization has bumped straight to 100%. And you can see the bump right here. And boom, 98%, and then 100%. And that has been going on for the last maybe 3 or 4 minutes. And so in the next few minutes, we should see that the trigger should capture and execute this policy when it goes beyond 90% for 2 periods of 5 minutes. Good. And that's what we are waiting for. But while it does, I'll talk about something different, related but different. So let me go and see how the stress is going. It's still going on, still running. You can see that this stress activity is stressing out the box. That's good. Now, stress is a good way to, rather one of the good ways to measure whether the customer will be happy or not. We talk about customer happiness, and I mentioned about grow policy and the customer experience, and I also mentioned that it is kind of vague to measure it. So we put a proxy, and then load time and response time, and then results, how quickly the results are obtained, all these metrics that we are really discussing right now. One such metric is CPU consumption. And as you know from our previous discussion, if the CPU consumption is beyond, say, 80-85% and higher, the situation translates to something which is what I call unable to respond quickly situation. When the machines are plugged in and are getting consumed at a very high level of CPU percent, beyond that, you will find that the machines that you have are not responsive. Let's go right click in Task Manager and see what this machine is doing to me. Is it responsive? It is close to the borderline. I mean, I just saw 85 number right there, and now it is 66, and now it is 70, and like that. That number of CPU consumption is kind of like on the borderline high situation. And this is okay. I mean, it's not good. Okay, I should say it's like, in a sense, it is most efficient use of resources. I'm using up my laptop to the best possible scenario. And how do I boost my numbers here? 64 number. I can bump it up by adding more workload, right? So if you look at, I am currently running this OneDrive business. I can quit it. And some other things I can afford to quit. Maybe the box sync can go, and iCloud can go, and all these things I can get rid of. But then it actually doesn't impact the overall CPU consumption, because those applications that I just exited did not materially impact the CPU. They were idling. The thing that is actually consuming CPU quite a bit is the Zoom meeting that is running right now. I'm transmitting my screen and my video to you. And that is quite a bit of hog, about 40% CPU hog. So from a scale perspective, I practically cannot, in a video conference setup like this, I cannot scale my machine out. I cannot do two machines and do two video conferences at the same time. Although I occasionally do, you may have seen that I will have another camera from there and another camera from there point at me. I'll do that occasionally. I'm not doing it today, by the way. Today, just one box, this box. So you can, in theory, scale, but individual usage does not scale out very nicely. But cloud scaling happens very beautifully if it is scaling out. You can scale out, and we are scaling out. We are going to scale out pretty soon. So from an individual perspective, the scaling factor can happen practically by looking at something like this. That you could go to your control panel and view the amount of CPU. The CPU is kind of lame. It is i5. Maybe I should get an i7. And it is only 8 GB RAM. Maybe I should get a bigger box. Maybe. But maybe not. Because if it works out okay, and if my customers are happy, and I'm assuming you are okay with my video conference experience, then I don't need to spend money on a bigger machine than a Core i5. That's what I'm saying. Is if my customers, meaning you, if you are happy with the experience that you're receiving from me, my video conference and screen sharing that you are looking at right now, and please, by the way, please tell me if you're happy or not, because that's the best way to measure happiness, is to just ask, hey, are you able to see my screen nicely or not? And if that's the case, I really should not spend money on a higher end machine than this, because then I am wasteful in effect. I am basically wasteful. When I say avoid waste, that's what I'm saying. Is I can, spend money and get a big machine like, which I will, by the way, eventually. I will buy a big machine. I'm waiting for this new iMac Pro to come out, which end of the year, which I will buy. And so that will happen. But I cannot, there's no such thing available in the market right now. So I'm waiting for it to happen by December. I will have a new box, big, gigantic box like I used to have. But that box is not there with me anymore because I gave it away. in expectation that, June 5th, which is Monday, we'll have a new Mac Pro announced, but I don't think they're announcing it. So I'm living with this Surface for now. So back here, our monitoring metrics, if you look at, it seems to be, about 5 minutes have passed, maybe more than 5. And so let's go see on a last 15 minutes what has happened in the maximum number in the last hour period. Let's say 1 minute period. So that should show us this is what time is 35 and 40. So we have a couple more minutes for the 10-minute period window to kick in, and then that kicks in.
Hey, I have a question real quick. I know it may be a dumb one, and I'm not thinking. Is there such a thing based off the policy that you have as like runaway elasticity? I mean, something to that effect, where you have an application server that gets in a twist lock or something where it maxes out on the processor, and then it notices that and then wants to deploy more servers, or grow out because of that. I mean, is that ever a factor, or am I thinking of this incorrectly?
I think what you're telling me is what you describe as run away or roll away. I want to get the right word from you. I heard you say run away. Is that right?
Yeah, runaway elasticity. I mean, I'm just making this up.
I get that. Yeah, I understand your concept. Let me describe the concept for others. So the concept you have is you have a setup and you have one box. That box is in panic. Panic as in pegged up 100% CPU, like this guy is right now. This guy here, 100% CPU, and the CPU metric went down because the run completed successfully in 610 seconds. Right, the box was in panic mode for the last 10 minutes. It was like hogging the CPU 100%. And what you are thinking about is a scenario of what you call runaway elasticity. That model is actually a good concept to think about. So I thank you for bringing it up. The idea that you have is if a box is getting hot, as in 100% utilization, for example, like that you were looking at right now, it is at 0% because the box is again busy doing nothing. It was busy doing 100%. Now it is busy doing 0%. If the box is in panic mode, 100%, the box should communicate to the infrastructure, hey, I need help. I need assistance. I need my utilization number to come down to below 85. Then all of us can live happily ever after. And that panic signal has to be sent to the infrastructure so that it can provision another box. In effect, what you're describing is runaway elasticity. Is a box tells another box to grow up and just add up so that we can distribute workload. And so I have 100% right now. If you come online, we'll load balance and both of us become 50-50 and we are all happy about it.
Correct.
And that concept is exactly what is implemented, but in the implementation, meaning the action to decide whether to create a new box or not, is done by somebody else, not the box. So that decision making has to happen outside by an independent entity or a machine that collects metrics. And that metric collection is what you're looking at here. You see the metrics going up all the way 100%, stayed there for about 10 minutes and then dropped. So this happened, right? This should have triggered an action that should lead us to believe that the policy must have kicked in. And so we are expecting to see something. What are we expecting? Right there, you see that. 2 machines right there. That came in. And that second machine is initializing. It is initializing because the trigger happened. What was the trigger? The trigger happened because of the monitoring that was done outside the box here. You saw that this metric went above 90% and stayed above 90% for a period of 2 consecutive periods of 500 seconds, which is basically 10 minutes. So I loaded up the box for 10 minutes, 10 seconds, 610 seconds, which basically triggered the threshold. And so when that happened, this independently done monitoring was able to decide whether it makes sense to kickstart one more box. And that is what you see has happened actually right now. And you can see that the activity history now has 2 entries. The first activity happened here. And this activity told us that, the instance was started in response to a difference between the desired capacity and actual capacity. The actual was 0, the desired capacity was 1, and so increase the capacity from 0 to 1. This happened like long time ago, like maybe 45 minutes ago. But now, just now, what has happened is this second action happened. What happened here? Let's go read. It tells us something, that at this time, a monitor alarm. So this is not a user request. It's a monitor alarm. And what you describe as runway elasticity, I want to disassociate that runway decision making away from the box itself and keep it outside the box to some other entity that is looking at the box independently and measuring it and then making a rational decision whether we should add one more box. Having the box itself decide that I need a box doesn't make sense, because what if the box is stuck doing nothing? I mean, what if the box is bad? What if the box is incorrectly loaded or has a bug in some fashion? Anyway, the box should not be a way to decide a grow or a shrink action. It should be done outside. A box should remain ephemeral. A box should contain just exactly what it's supposed to do, which is to run the application. That's it, nothing else. Everything else should be outside, somewhere else. Everything that you provision in your cloud, in your application, should have ideally one goal in life. I will do that one goal and I'll do it really, really nice. That is the best way to think about cloud infra, just anything in life, I would say. Here is this principle that you should think about. Unix philosophy. So read that philosophy. It actually makes a lot of sense. So go click on this link. And this philosophy, one of them is number 5 is the best one. That philosophy. It is saying, do one thing, do it well. That's how you should think about everything you do as a person, everything your machines do in their life, in machine's life. That's how you should think. Is a box should do what it does. Run your app, boom, that's it. If you want to scale out, scale in, you have to have a separate thing that will deal with just that thing of scaling out, scaling in, decision making, and nothing else. If you have something else that needs to happen, like for example, monitoring this action of whether this box that we have is actually getting hot or not, I mean getting CPU pegged or not, this particular monitoring does not happen at the box level. It is happening outside of that box through an independent service that Amazon calls CloudWatch. That's a separate service different from the box itself. If you want to monitor the box, you can monitor it directly on the box like I'm doing here. This monitoring that I'm running, HTOP, here. HTOP is a tool to measure, right there, HTOP is a tool to measure CPU performance. So I installed it and I ran it, and this is like the box monitoring itself. I mean, I'm monitoring the box directly sitting on the box and it's saying 0% CPU, it's good. I mean, yeah, but this is not what I'm talking about. I'm talking about independently monitoring through an outside service like this that looks at the box, measures its performance, and keeps track of metrics. That's the whole purpose of that service, is to do that one thing, is to monitor. And this is a separate service. This service is called auto scaling, and its purpose is that one purpose, which is to decide whether to grow or shrink. And apparently now it is decided to shrink on itself. And you know why it decided to shrink? And it is shrinking right now. It is doing that shrinking thing right now because you can tell why. It is shrinking because there is no load on those two boxes we had. And so here in this successful step that we have, it did this thing, monitor alarm triggered something. It triggered what? It triggered the policy. Which policy? The up policy. Scale up, meaning grow policy. The grow policy was triggered by an alarm happened. What was the alarm? You know the alarm, 90% CPU for 2 consecutive periods of more than 500 seconds. That's the alarm. The alarm triggered through a monitoring service known as CloudWatch in the case of Amazon. And so that alarm triggered, it decided to kick in the up policy, which is grow policy. And then as a response of that, changing the desired capacity from 1 to 2. That's it. It just changed the desire from 1 to 2 because I want to now grow up, or I should say grow out. And so, so at that time, an instance was started in response to a difference between the desired and actual capacity, and therefore increasing the capacity from 1 to 2. And that resulted in a grow action. Now this activity is happening again in a different service, not on the box, separate service known as auto scaling. That's what you're looking at right now. Now let us go see what this third action is happening, which is expected. It is expected because our machine here is doing nothing. And not only that, the other machine that we started in response to this heavy workload we put on this, on the stress, this stress that we put here, that stress caused 100% on this box, which led to creation of a different box. Now both of these boxes are doing nothing. So what do you think will happen? It's going to drain a box, kill a box, terminate a box, extinguish a box, and maybe shrink a box or something like that. So let's go see what is going on. So it's waiting for something to happen because the alarm is triggered. So alarm triggered, what does that mean? So it says terminating EC2 instance, waiting for ELB connection draining. Let's go read the cause. The cause is at this time, a monitor alarm, some alarm called something in alarm triggered a policy. The policy that was triggered was the scale down policy, meaning shrink policy. And this policy changed the desired capacity from 2 to 1. It basically changed the desire from 2. We don't need 2, we need 1. So that's the desired change. When the desire changes, then at this time, which is almost at the same time, maybe a little bit of few seconds later, this was 13, this is 18, so 5 seconds later. No, yeah. Five seconds later, an instance was taken out of service in response to a difference between the desired capacity and actual capacity, shrinking the capacity from 2 to 1. And so this machine was selected for termination. So the box was decided to be killed. So we'll go here to the EC2 dashboard and see that the box is dead by now. And here it is. We have only one box running. One of them is dead. And the other box died because we wanted it dead. I mean, we did not explicitly say that you kill it. We said, you know, it actually exited on us because the machine died, system going down for power off now. So the machine that we were connected to was killed. And so we don't have a connected machine right now in the Amazon cloud because it was killed out. And as a consequence, we are back in our workstation. But this, I think, helps you understand the scenario that I'm painting, which is a design pattern, mostly. The design pattern we just saw in real action was the idea of bunch of things put together here. let's understand those pieces that we've got things together. So we began discussing with the idea of scaling, right? Scaling as in you have one machine here, another machine running the same application, another machine same application. And we were able to put this in a structure of what we call auto scaling group. That's the name Amazon uses. Other companies also use the similar terminology. So the terminology is fairly similar here. Auto scaling, that's the concept. The idea is you have to have a grow policy and a shrink policy. You need to decide what constitutes an action that leads to a grow action and what should constitute a shrink action. So the trigger you need to set. The trigger needs to be set based on measurements. And measurements need to be done by some kind of a service, or maybe you have another machine that does one thing, which is to measure. So you have to have a method of measuring something that you will then keep track of. And as soon as the measurements will trigger something, will then lead to an action of grow or an action of shrink. And when these things happen, your machines will shrink or grow, depending on what you want. And so they will grow back again if you like, depending on all again based on triggers. And triggers are based on measurements. And measurements, you need to be very, very careful as to what you really want to measure. If you measure the wrong thing, you will get wrong results. So be very careful and diligent in understanding what makes customer happy and measure exactly that. This itself is very hard to measure. How do you measure customer happiness on a machine level? It's very hard. I agree. So you come up with a proxy, and that proxy has to be decent, or rather half decent at least. If that proxy has no method of correlating it back to customers' happiness, that's a bad proxy. Don't use it. So spend most of your time in this specific discussion, which is critical. The critical discussion here is, what do I want to measure that actually translates to measuring whether customers are happy or not? And that piece is the most critical thing in auto scaling. Everything else is kind of simple. You saw it already. You know, we used a proxy here. The proxy we used was CPU consumption, CPU percent, you know, some percent consumption. And the trigger that we used was now more than 90 for a period of 10 minutes, or rather 2 times 5 minutes, 2 periods of 5 minutes. That's the trigger we used. More than 90% CPU, and that triggers a grow policy and a shrink policy. But the question is this the right metric for your customer happiness? Maybe, maybe not. It may not be, because in cases where something else may be a problem, CPU alone cannot answer the question. Maybe it is memory consumption. Maybe it is your network latency. Maybe it is the response of your database server on the back end. Maybe it is the bandwidth that you have between your service and the customer. Maybe there is something else that is very, very measurable, but it has to translate for your given application that you have. It has to translate that back to customers' happiness. And then you spend a bunch of your time critically thinking, what are those metrics that you need to measure that will act as a decent proxy for customer happiness? If anything else that you think about that doesn't borderline leads to customer happiness or unhappiness, you don't worry about it. Don't worry about measuring that. Don't worry about using it as a trigger. Don't worry about using that as action that will lead to a grow policy or a shrink policy, because all of these things are irrelevant. The only relevant, really relevant thing is this. That's the only thing that is relevant. Everything else, all these numbers, yeah, they're proxies. We don't really care about the CPU 100% or 500%. I don't care. All I care about is whether the customer is happy or not. Because if that is the case, I have no problem in my life. I mean, the way is not everybody can actually do it, but I have the benefit of asking you directly, hey guys, how are we doing? Are you happy? I can ask that right away, right in your face, and you can tell me whether I suck or whether you're okay with me. that feedback I have, that ability to gather directly from you. So I don't have to spend too much time on worrying about, hey, what these things are going on, and how is my Zoom conference going, or how is the website performing, because you can tell me. You can come and yell at me, or maybe do a Slack chat with me and say, Nilesh, this thing doesn't work. I mean, I can fix it, or at least I hope. But that luxury is not available in every business. You cannot reach out to your customers and say, hey, how are you doing every time? Imagine Windows as a Microsoft as a company asking every Windows customers, how is Windows running for you, and what do you think they will receive back? And that's a hard thing, right? So you have to come up with proxies that are relevant. And that is the most of the time that you need to spend on making sure that you tweak your infrastructure to address this, because everything else is useless. Okay, so that was one this discussion. Let me go back in that cloud and make sure that the thing is terminated, and then I will go back to my what's called cloud formation right there, and terminate the stack that we have created, right? So I'll, like Terraform destroy, I will say cloud former you action delete the stack and get rid of everything I have there. So it is starting to delete the whole thing, and the whole thing will disappear. So that's the beauty of these tools, is it makes it easy, right? You know, you want to create something complex, you write that down in form of Terraform files, like we did the other day, like here. Come on, there. And so you write that down in a specific descriptive format in a folder, and then ask Terraform to run using that. That will construct your cloud the way you want, and you can then destroy it the way whenever you feel like, or you can recreate it in another location. Similar tools we used today again was the CloudFormation tool. Now let us take a short break, and we will start discussing something about Docker. I'll give you one more exercise to play with, and so you should be able to understand those things a little bit in further detail on Docker. And what I intend to do is take a short break. So I will start it, and any questions are welcome even during the break. And the timer goes right now. Restart. Oh, there it comes. Hey guys.
English.
Okay, so you're back. Let's see who else is here. Okay. You people are coming back. Nice. So let's continue our design patterns discussion. The thing that I want to talk about is, again, repeating this one more time. Do one thing, do it well. That's how you should think about every application, every service that you put together. This is the foundation of Linux. This is the foundation of Unix, by the way. This is the design philosophy of you should read more. You should read this whole Wikipedia article to help us understand what these guys did to build Unix and Linux. And this is the foundation of the operating system as to how the thinking behind where do you put a given workload, in which process do you put it, in which binary structure you put, in which package you put, in which box you put, in which container you put. And this is the philosophy that has evolved into what is today known as microservices architecture, where you do that one set of service in a clearly contained fashion, and you run that thing only in that location, in that context. And you basically follow that same. So you should read that, by the way, the Unix philosophy page on Wikipedia. You should absolutely read that. I'm closing some of the tabs here that are not necessary because they might distract me. And so I'm closing them out. And I will continue our discussion on design patterns, variety of design patterns that we can put pieces together. So we discussed a couple of them today, and we'll discuss more as we go along. So back in our white sheet of paper. One of the things that you will see in a typical description of a given application is that there are a variety of things to accomplish from a customer's usage perspective. So this picture that you're looking at is just a simple example of a two-tier application with a load balancing tier and an application tier. That's a very simple way to think about and all of this inside a VPC. That's the way to represent this picture to get us to a point where we can discuss the implementation of a given design using Terraform as a tool. But if you extend the same idea and look at a variety of different examples available in the industry, there are these two companies that have spent quite a bit of time and effort and energy in putting together a variety of reference architectures. And one of them is this site, which I think I would like you to point out to you that there are some things here that are really useful that you should take a look at. And I'll highlight a couple of those here. In addition to this, there is this other company called Amazon, which also has put together quite a bit of design reference architectures in the Architecture Center by Amazon, and which also has a large collection of things that you can use as a ready-made reference design for deploying a variety of scenarios. For example, link server and exchange server and PowerShell desired state configuration. This is something that Chris was interested in, Chris Taylor. And so that's what you should go and begin reading. And then, if you are interested in studying this DSC specifically, I suggest that you and I do a one-on-one, because I know you are interested in DSC. So that is something that you should start reading about. How do you take a Windows PowerShell based desired state configuration, push and pull server environment on the AWS using Active Directory, and you can do this outside of Azure to get a perspective of how it is done on other clouds. So that will be a good one for you to study. Now, most of these applications are application specific. So for example, Link, Exchange, PowerShell, SharePoint, RDP Gateway, Active Directory, SQL Server, ADFS. most of these are commonly used industry applications: SAP HANA, SAP, Cloudera, Hadoop implementation, MongoDB database implementation, Magento, Ansible Tower, Chef Server. We have done this already, by the way. We set up our own Chef Server. NIST is a reference architecture for AWS Enterprise Accelerator, Puppet deployment. PCI DSS is a compliance standard for industry standard security for financial transactions. And so if you want to create a cloud setup that matches and meets the need of PCI data security standards, you follow that guideline that they have given here in this document and basically extend the same idea. By the way, you will find something very, very useful and interesting as you go along in real life. For all these examples that you're looking at, you will find ready-made templates to use. And I'll give you a quick example with this PCI DSS. If you're helping a company set up PCI compliant credit card infrastructure for them taking electronic payments on the internet, they need to follow the PCI DSS standards. And so there is this PDF file that you need to go and look. And you can, of course, look at it. And that PDF file will open it up and you follow that. And this is more like a human being reading the document and all that. That takes a lot of time to read. And so if you want to just quickly get to a point where you can get to a result very, very quickly, you can accomplish that fairly easily. And so the way to think about it is that if you go to GitHub, you will find an example of every single thing that I described in that sheet of paper. You will find GitHub PCI DSS template. And there should be this one. This company actually is a local Seattle company of Vian Consulting, and they have given a sample template that you can just take it and apply into some cloud. I think they have given a sample for AWS, Azure Cloud, I think. So you can go and let's see which was the right one. Maybe this one. Yeah. So payment card industry, PCI DSS. There are these templates available. They're still working on it like 5 hours ago. Okay, people are busy. And so you can read this README and apply the template, the design template available in the reference architecture here. Apply that to these resources. There is a resource manager. So this Azure deploy parameters JSON file is what you need to take and apply to the Azure cloud. And as a result, you will receive a cloud design implementation that matches the PCI DSS guidelines. That is basically a ready way to quick and easy way to deploy to get you started in the direction that you would like to go if you have a customer that expects you to set up PCI DSS for them. How do you get to that point? You go to GitHub, find out if there are ready templates and get them going in the cloud. For example, this is an Azure template. So like I mentioned about JSON templates, this is a JSON file that maps itself to the Azure cloud and it will set up PCI DSS reference architecture implementation for you in your Azure account according to the PCI standards. That will get you something going to begin with. Then you can go back and read that piece of paper and compare. Okay, what do we got? What do we need to have? What does the customer have in mind? And then compare contrast and find out what the differences are between what the desired state is and what the actual state is. And then you align them. Like, the desire from the customer can be something different than what you get in the implementation. And according to this reference architecture, this JSON file, you might see some differences. So you come back here and tweak this JSON or tweak that design that you have in the cloud that you are dealing with and make sure that the desire meets the actual meets the desire. That's what you need to align. And once you align, you can then give that solution to the customer and make them happy. And that's how you should think about all these design implementations that people describe. And there will be a bunch of these, like here, Docker EE. How do you deploy Docker Enterprise Edition? How do you deploy Splunk Enterprise, Spinnaker, and Nginx, and Amazon VPC? We have done this Amazon VPC exercise ourselves. Linux Bastion host. This is like the first exercise we did long ago. Like the very first exercise is that exercise. Bastion host, which is basically a foot in the door in the VPC that you can hop through and then get inside through SSH proxy command. Here is another example for Oracle database. Here is an example for Bitbucket, Jira, Swift for Apple development, CI/CD pipeline, HashiCorp console, Vault, and a bunch of other commercial software. You can see Tableau software, Confluent platform, Confluence, Kubernetes. We'll have an exercise on Kubernetes ourselves. We'll do this one pretty soon in the next 2 or 3 days. That is a very, very popular thing to keep track of and actually practice, because that thing is growing like crazy. I mean, I'll show you how crazy it is. Look at Kubernetes. This is a Google product, but it is on open source. There are 1,226 contributors. There are 49,000 commits, and it is amazingly useful product. What it does is helps you run containers in production with fairly easy to use method, and that's the tool that is amazingly popular. If you have seen this game that you may have heard of, or I'm sure you played with it. The game is called Pokemon Go. You know this thing, Pokemon Go, right? I'm pretty sure you've heard of this at least, if not played it. And that game, at its peak, was crazy popular, like the most played, downloaded and played game on the App Store ever. That's this game. And let me tell you, the back end of this game, on the back side, the cloud side, is Kubernetes. And it is on the Google Cloud. And so here, bringing Pokemon Go to life. And there is a case study on that. You can read more about how they did, about implementing the backend needed to run Pokemon Go on a global scale using Kubernetes. And this company, Niantic, which created that app for the Pokemon Go app, used Google Cloud and Kubernetes on the back end to make it run. And it succeeded, apparently. It's still pretty popular, although not as crazy as it's not in the news anymore, but it is still useful. People play it. And so back in here, those examples all the way up to this point are custom specific applications that you need to have. If you need to have those applications, you can use those designs implemented as a reference given to us by this Amazon company. However, there are certain other cases which are not tied to a particular application. They're more in terms of a general purpose reference implementation of an idea, not an application. So these GitHub Enterprise or Confluent platforms, there are specific applications. How do you install this application versus that application? So that's a different discussion than what this discussion is. It's a reference discussion for a given type of application. And so we have discussed at least one of these guys already. I know we discussed quite a bit in depth this particular media sharing PDF file. You probably remember this in the Netflix discussion. But then all other files are also very, very useful to understand because they are applicable to a variety of designs. And what I want to do is take a moment to at least go through some of those things that you may be interested in. If you want me to skip, there is too much material to cover. If you want me to skip something, just tell me to skip ahead and I will skip. But I want to highlight a couple of key things. And what I have done is downloaded those PDFs and put them in a bundle here. And we'll begin with number 1. which is I want to have a quick discussion on these things to help you understand how do you, or rather how does Amazon want you to believe that the right way to deploy a particular given application is. So this is the Amazon's way of doing things. They recommend that you follow these steps, and they also recommend using the Amazon cloud, but let me tell you, it's not necessary. You can choose whatever cloud you like. And so in here, the focus is on getting web application hosting. So this is similar to what you will get in any host where you have an application. That application will be sitting here. And the application will do some computation for you and will then present that output, and it will also scale. So this is a scaling group here. Multiple machines scaling application servers. So you have to have your application that scales like this in an auto scaling group, and this is front-ended by a load balancer, which is, by the way, an internal load balancer. Internal. It is inside. Customer doesn't hit this load balancer yet. Customers are here outside. They will hit your external load balancer, and these external load balancer will then be connecting and sharing the load across the multiple web servers. So there are two layers here. There is a load balancer layer, external load balancer. There is a web layer. Then there is another load balancer, which is internal, and then there is application servers. So this load balancer is an external one, which is what customers will typically access. And depending on the load that these customers are putting on, these number of W web servers will scale like this, auto scale, grow and shrink. The policy you need to decide as to what constitutes customer happiness, and that is what you need to tweak in your policy for you to be able to grow and shrink these web servers according to customer need. And then these web servers will in turn might hit the backend, which might require some processing. And that processing is done by these application servers, which also grow and shrink depending on the need of the customer. And the customer for these guys is this. So the web servers are the customers for your application servers. So for those of you who do not know the clear distinction between a web server and an application server, I would like to describe that. And so the idea behind a web server is purely something that is just rendering something as a, I think this design, I want to clean it up. Let me go and close and don't save, and then open up again. That's the easiest way to go back. So the way to think about web servers versus application servers is as simple as, if I want to just have something readily available, I want to just serve it to a customer. I don't need to do any computation. That item I might have readily available to me. I can just service it and give it to the customer. But if there is something that requires computation and some number crunching or some analysis, I need to offload that to another machine, and that is this application server, which in turn might go back again one level deeper and go to a database and then receive information from the database before it actually processes whatever is needed by the web server, which in turn will then return back the data to the customer. So that's the level of tiers. So this is tier number 1, and this is another tier, and this is the third tier, tier number 3 for databases. So the databases are also replicated, but you are actually accessing it only on one point. There is no connection between here and here. So there is no such line here. That line doesn't exist. And that is something you need to remember, that this replication is a master-slave replication. So this is a master database, this is a standby database, and they will replicate and they will fail over when you need to, but databases are not scalable like you will see this setup, auto scaling setup. They're scaled differently. That's what I want to point out. And that's a simple example of a multi-tier application hosted on the web, where you have some static content that sits in your bucket, is served directly through some kind of a content delivery network such as CDN, and its service given directly to the customer without even having to go all these places. So without touching here, you can just directly receive static objects directly from a bucket. And for dynamic objects, you have web server, application server, and database server collectively operating to render the dynamic portions of your content on your site. That's the example here. If you have any questions at any time, please ask away. I'm going to rush through this a little bit to make sure that I help you understand. So the item number 2 here is media, which I think we have covered quite a bit. No, not this, but here a very simple one: live stream source. This source is me right now. We are doing it. This scenario of media and content streaming is happening right now as I speak. This is live stream source, me sending data to a media server, which is run by the Zoom company, and it is going out to you. You are the end user. You're also running an application, which is the Zoom application, which is receiving content from the Zoom server directly, like this. And that scenario we are playing right now. This setup is not in the Amazon cloud, but the discussion is also not about Amazon cloud. We are using Amazon pieces of PDF files, but it is not about Amazon. It is about live stream content serving. So this is a scenario where you are doing some streaming and lots of people at the same time, like all of you, are watching it live. That's one scenario. The second scenario, let me open it up again. The second scenario is when I will have a recorded file stored with me. I will put that somewhere in a bucket, or maybe I'll put it in Vimeo, or maybe I put it in YouTube or some other location, and that video will render to you when you want to watch it, whenever you want to watch it, on demand. So that on-demand videos are available in this location. You probably know it already. You go there already, right? You know, recordings here, and you can see them. They just show up here because I add them there. And these recordings are coming not from the Cloud Genius server. I just want you to know this. They're coming from different places. For example, this one is coming from YouTube. And this one is coming from Vimeo. This video is coming from Vimeo.com, not on YouTube. This third video is YouTube. Maybe not. Yeah, it is YouTube. Fourth is also YouTube. And so these 4 videos that I have are basically an illustration. I deliberately added this video here, YouTube video, and it tells me internet connection is unstable. That's crazy. But if that's the case, please tell me the internet is bad or something. Just let me know. So the idea that I'm describing again is that static content that is stored in a bucket can stream to you through a different method. It does not need to come through a live stream. That's a different scenario. I think you understand this. So I'm closing it out. If you have any questions on any of these design ideas, please stop me. Ask me those questions. Moving ahead. Next one, we have batch processing. This batch processing idea is similar to the idea of a driver license office, in a sense that when you visit Department of Motor Vehicles, let's go there. So we are here at the DMV, and this is you, this is me, and other people waiting, right? And here are the officers, officer number 1, officer number 2, 2 people just giving us licenses. So you are, here waiting for a driver's license, and you have, your license is expired, you want a new one. So you just show up. You say, hey, traffic cop, where should I go? So this person should go here. So you go there. Now this person, officer number 1, is going to meet you and tell you that, hey dude, I would like you to take this temporary license and your permanent license will be mailed to you in the mail in about 6 to 8 weeks. And that is when you'll receive a piece of plastic. And so you feel happy about receiving the temporary license, and you go away. You go home with the paper license, not plastic. And you feel happy about it. Great. In the meanwhile, I am waiting. And I need to get my license also. So eventually I will receive the license. I will follow the same steps, and I will also get a temporary paper license. But what if you insisted that I need to get a plastic license right there and right now, not paper, temporary? What will happen? This processing of a piece of plastic might take a little bit longer time for the officer to create, and they may not have facilities right in their office. So it might take a little bit longer time. In the meanwhile, everybody else is getting more frustrated. That's the whole purpose of issuing a temporary paper license, is to shrink the amount of time you have to wait here, so we can let you go to do whatever you want. And the back end gets busy doing processing plastic licenses, the actual pieces of plastic that you see in your credit card size in your mail that you receive. It takes time, and that's why it is not done immediately. So what do? You run them in a batch process. And you, by the way, when you're running this in a batch process, you don't need a skilled officer. You can use a cheaper officer. Cheaper officer. It's a bad analogy, but you can use what I call spot instances. That's a better way to say it. You can use spot instances to process. Sorry, I did not get it.
I was going to say a contractor or a CSG contingent staff.
Yeah, you can say that. You can say it that way. And so, so a skilled officer is not necessary. And so you basically don't get an on-demand machine, but you get a spot machine. And then you put them in a back-end job and do them in a batch process. It doesn't matter if it happens next week or the week after, because who cares? We already told them 6 to 8 weeks. So you can do whenever you feel like, basically, and then get the plastic ready and then mail it to them. And that's the idea, right? So that same idea applies here. It's batch processing. Well, the idea is that you have a queue. A queue is something which is like a pile of stuff, right? I piled my stuff and I put my things to do. I need to prepare a license for Mr. Chris Taylor, and for Nilesh, and for you, and for me, like that, right? So I'm piling up my work. This is a pile of stuff, things to do. That's an input queue. And so somewhere, somebody has to put an entry in the queue. A queue, they're using a queue service. You can create your own queue using a software called queuing software. You can create it very easy. What do? You find a software in open source and you look for its ready-made Docker Hub image, and you try that image. That's the easiest way to get an image ready, right? So just find a queue software, put it in a Docker image, run the image, and you have a queue going. Boom. I just built a queuing system. Ha! That's how it really works in real life. You just readily use ready-made open source software. That's the fastest way to get to a solution. So just get a queue, you pile up your stuff to do, and then what? You put worker nodes. These are the cheapo officers I mentioned, right? Cheapo machines, spot instances, and you can put them in auto scaling. And when the result comes out, you put them in the output queue. And then you can optionally chain other dependent actions. The next action is optional chaining, meaning I get the plastic ready and I have the plastic piled up here. So I have the plastic driver licenses piled up here. They need to be mailed out, right? The mailing action is the next action. So it's a chained action, chaining. The next action is, now that I have a pile of work to be done, this work is to mail the plastic. So that is a chained action. You need to assign it to somebody else, even cheaper than the cheapo officer. Like, for example, a mail person. All they need to do is just stick the label, put it in an envelope, stick the stamp, and boom. That's the idea. That's the action. That's the optional chaining action, which is a subsequent action. You can put things together. And the computing implementation of this would look something like this. I'll erase this screen and come back to it again right now. Here, opening it up. In computational implementation, you might have some kind of a queue that will have a pile of things to do, and you will do those things in the worker nodes in auto scaling group using cheapo nodes, and you have another queue ready. This queue contains notifications that need to go, right? So in electronic notifications, you will have to, like mailing, for example, using a postage paid envelope, and you mail. Similar to that, in electronic communication, you email. And so this email action is a queue that needs to be sent to an email server. And so, or a service, depending on what you want to choose. So you can use an email service to outsource this queue getting processed. And for that, there are web services available right here. In every cloud company will provide you some kind of an email service. Let's go see what they have in the Amazon cloud. So we'll go there and see if you have an email service. Show it to me. So it'll show it to us. And so we'll go see that cloud, my account, and come on, show me the console. In the console, you have a variety of services, and we will find out where the email service is, and it should be there. They have a name for it, and I'm forgetting the name. And so the name is here, SES. That's the name, SES. So you click on it, and it's a service that exactly does what I just said, is simple email service. So you have a queue somewhere, and you want to send a bunch of messages out, emails out to people. You know their email addresses, you know the body, the subject line and everything. And you just need somebody to send those emails, right? So you use this service. It's, basically junk mail service or notification service. People use this for a variety of purposes. People use this to send junk. People use this to send notifications. But by the way, sending junk is a bad idea. And so don't do that. I'm sure you will not do that. But people have misused this service to send junk, by the way, just so you know. And simple email service will basically help you accomplish the same idea, which is, optional chaining. You have a queue, you want to send emails, connect to the service that I just described to you. SES, simple email service, and boom, 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 it sends out email notifications. If you want to send out text messages, you go to another service, go find it, and go to the cloud and say, hey, I want to send SMS. So you go to this service, it's called Twilio, and you connect to them using an API, and that Twilio service will do exactly what I just said. You have to send text messages, so you get the API key, you log in, and then it'll let you send voice SMS, video SMS, iMessage messages, variety of new services they're adding on. I'm not sure about iMessage, but regular text messages, yes, it does. That's the primary business that these guys are in this service for, and they will have a API kit for PHP, JavaScript, .NET, Java, Python, Ruby, iOS, and Android. And you can send SMS once you want to. Once you have a output queue, you want to notify your customers, hey, your thing is ready, here is an SMS. And so instead of email service, you say SMS service. And you don't use simple email service, you use Twilio. And that's the way to connect your services. You put things together. The way to think about these things is to always think about one thing at a time and identify the best solution to put that together. So at this stage, if I'm looking at, sending my SMS, that's the only thing I will need to look for. And I will put together a solution that will be focused on sending SMS. And I will identify either a service provider or hack together my own solution or use a ready-made open source solution. One of those three things. And you build by partner, and you find a way to solve the need that you have, is to address the output queue, bring the queue down to 0, eliminate the pile of work accumulated. You want to send SMS, then go send it. And for that, you build a segment of your infrastructure that will address that particular need. And then when you're done, you focus on other things. So you discard this, and then you open it up again, and you look at other pieces that need to be accomplished. So you already took care of this input queue, output queue, a message sent out. Your work is probably done from that perspective. You might want to also do some analysis about what have you done in the past. And so you store that detail about what have you done, how much work has been accomplished in the input queue and the output queue and all that, by storing that in a database and then analyzing that detail. And then you can do that analysis separately in a separate system in an EC2 machine and maybe analyzed. That depends on your business use case. If you have a need to analyze or not, really depends on you. But that's this idea of this implementation idea that they're describing here. Let's go next. This one. This one is, I think, about fault tolerance and high availability. So the scenario here is basically as it describes. What does it do? Fault tolerance. You basically, when you want to have high fault tolerance and you want to be able to tolerate fault, you need to do this in two distinctly different availability zones, A and B. These two distinctly different availability zones that you will have identical setup in both the locations. So if you draw a line like this, you will have something here, database server here, database server here, application server here, application server here, web servers here, web servers here. So you have redundancy. And that redundancy comes in at a cost. Everything actually is double the cost. Whatever you have on this side is repeated on this side. And that is a necessary evil. That's how you accomplish fault tolerance. You spend twice. And if you're spending twice, you get the benefit of being able to suddenly go, one of the regions sorry, why does it not go away? I wanted the markings to go away. Discard changes and open it up again, please. And so if you want a situation where you have your infrastructure, that you want it to be highly, highly available and tolerant of faults that might occur in a given availability zone, you need to spend twice the amount and fail over when some things go bad. When something goes bad here, somewhere along the chain, then you don't worry, because your customers will continue to perform and they will be delivered the result that they expect to see, because you have a redundant, separate, identical setup that basically fails over with the ability to fail over across to the other availability zone. When things go bad, you can immediately, transparently fail over without having this customer impacted at all. That's the scenario that they're describing here. However, in this setup, sometimes what Amazon is suggesting in this other part of the picture is that you could keep a standby, an active, and a replacement as it kicks in. So they're illustrating the same point of view where a machine is active here, and if something goes bad, your replacement is created, and you can then transition from this being active to this being active. And then it is not standby anymore. This becomes dead, and this becomes your replacement, which then eventually becomes a standby, and that remains active. So that in the picture, they're trying to illustrate this point of transition as to when things will change over from active to standby when something goes bad. So on failure, something happens, your active machines will be dead, your standby machines becomes active, and you have a replacement coming up. When the replacement comes along, it becomes your standby and your traffic will go that direction. Like that. That's the concept they're trying to illustrate, is how they recommend fault tolerance should be implemented. Let's go to the next sheet of paper. What is this? Large scale. It's coming up. Here, they're describing about huge data sets. And a huge data set basically means you have a ton of data. So an example of data coming in can be it can vary from business to business. So an example of data coming into your company. I mean, I'll take your company's example. Amazing amount of data comes into your company from the planes that fly. The plane that flies, and not just one, millions, I don't know how many planes you have worldwide, but these planes that fly, that Boeing has created, these planes will generate, they actually actively generate a ton of data, like a ton of data already, all the time. And at some point in time, or maybe almost instantaneously, depending on the need of the plane's data, it will either dump a bunch of data as it lands, or sometimes it will transmit the data live as it flies. Both scenarios happen. And that high throughput of data, parallel upload of data, will come from the plane itself. The plane will send you data about what is going on, where is it flying, what pieces of components and functioning parts, or I don't even know the parts of a plane, to be honest, because I have no idea. But yeah, maybe there's an engine and the propeller, and maybe there's no propeller, there's a jet engine and things of that nature. Maybe a seat is malfunctioning, maybe the TV or the game machine is not operative, the lights are not functioning, the temperature is not right, and the pressure is not right. 100 other metrics, maybe not 100, thousands of metrics are collected every single point in time, depending on the metric or the frequency of collection. And that data is gathered at the plane level. If the data is critical, it will be sent down to the ground. If the data is not so critical, it will wait for the plane to land. And when the plane lands, that data is transmitted to Boeing. Boeing collects that data. Huge data set is the right way to describe, because that is huge. Another example of huge data set is Tesla. When a person drives a Tesla, Tesla is collecting about 10 gigabytes of data in every mile it drives. 10 GB. I mean, that's enormous. And not all of this 10 GB data can be simultaneously in real time sent to the Tesla company. So it eventually sends it, not all of it, but some of it, because all of that data is not necessarily useful. And so people talk about big data and Hadoop and all these other technologies, but practically speaking, it is not about all the data. It's about all the relevant data that needs to be captured. All the relevant data. It doesn't have to be all the data, because it is not practically feasible to send every single video that a Tesla will capture from all its 9 cameras around itself. It's not practically possible. Eventually, technologies will evolve and maybe something else will happen. But today, 10 GB of data per every mile of travel, and capturing that and sending it over to the Tesla company on a LTE connection is not technically possible. I can drive Tesla in like hundreds of miles in a couple of hours, and that will accumulate like how many gigabytes? Oh my God, gigabytes. And I cannot transmit gigabytes of information through an LTE connection on the Tesla. So that's a fact I have seen myself. But that's how I'm talking about, is collection of huge data sets. There are one more example. Energy companies, gas pipeline across going in our area from, I think, from Seattle all the way to Canada. It goes and it passes through King County. That pipeline is the Williams Communications pipeline. It runs natural gas. Now, this gas pipeline contains gas, of course, but we want to make sure that we are measuring every relevant thing across as the pipe flows the gas, so that we are on top of any disaster that may be brewing. Right? We want to measure the flow. whether the flow is laminar, whether temperature is correct, and all the spots across the gas pipe as it is distributing gas to households and businesses wherever they need that gas. That need of every little metric around the gas pipeline needs to be measured by the energy company. And that is another huge set of data. So I'm just giving you 3 flavors: Boeing, Tesla, gas company, collecting a bunch of data. But what do we do with it? That's the next question, right? So I'm going to unsave, not save these things, open it up again, and understand what do we do with the data. Now that we have the data being sent to a central location, we want to do first thing I want to do is put that in a bucket. Now that we have in the bucket, we can then begin to read and write from it. And once we read and write, we want to understand what to do with the data. So that requires some processing, which requires machines. And these machines can then run whatever code you want to run. For example, people will use these days Spark application or Hadoop application. These are both Apache projects in open source. And people will use other variety of implementation. So most cloud companies will have a Hadoop implementation, a Spark implementation, and they'll give you a bunch of other related toolings to make things make sense out of the data that you're accumulating, huge data sets, and for which you require machines that you will have to be able to scale out and then produce some results from the analysis that these software will do, and then store that result back into a bucket and maybe do further processing. So that's the structure that they're describing here in terms of huge data sets. I'm going to close this out, and we timed out. So we'll continue. We'll continue this. There are a lot more, I think about 13 or 15 or so of these. I'll spend maybe 5 to 10 minutes in each one of them, and then we'll transition to a hands-on exercise next time. Next time we will do, you finish this off and then jump into Docker related exercise, which is right somewhere here. Let me point it out to you. I think it's written down in the website in this location, and there is a pre-recorded video for that also. So I'm going to point it out to you, and that is Docker based multi-tier. That thing should be it. So number 7 is where I have it written down, and there is a video for that. Is it? Yes. So this video actually runs you through the exercise. You don't have to watch this video. I will run it live for you and make a little update to that exercise, which is in this Git repository. I have stored the exercise itself, and this will give you a solid understanding of how to get Docker to do things for you for a given variety of applications. We'll run real live applications in this exercise, 3 or 4 of them, all in Docker, everything in Docker, using this tool that comes with Docker called Docker Compose. And that is what we will be using the next time. The code is available in this location, GitHub, and the how to use that is in this video, but don't worry watching it. I'll do it live. And with that, I'm pausing recording and open for questions.